Hello Year 10. Today we are going to be factorising polynomials to find zeros. Before we do that, we just want to do a quick revision of our last few lessons. So in question 1, we want to find the domain and range of y equals minus x squared plus 2. Y equals minus x squared plus 2 is a parabola. The y-intercept of the parabola is at 2, and because it's a negative x squared, the parabola is going to be concave down like that. So I'm not finding the x-intercepts, but I just want to know what the graph looks like very roughly. So looking at that graph, the domain represents the possible x values for that graph, and it can be anything. I could sub in any x value and get a y value. So we call that all real x. The range represents the possible y values. The highest y value that my graph will ever reach is this turning point, which is at 2. So that means my y values will always be less than or equal to the number 2. Question 2. Find the remainder when the polynomial is divided by x minus 1. Now you could do a long division and find that, but we learned about the remainder theorem, which is if we sub in p of the opposite of minus 1 is a plus 1, so we sub in p of a plus 1 into the polynomial, then it will tell us the remainder. So subbing that into my equation, I'm subbing in that x is equal to 1. I get 1 cubed minus 4 times 1 squared plus 6 times 1 minus 1, and that is equal to 2. So the remainder is 2. Okay, on to our new work. To factorise a polynomial, follow the following steps. We have to find one factor using the remainder and factor theorems. So we usually start with x equals 1, move on to minus 1, then plus or minus 2, etc., until we find a factor. Then it says it's a good idea to first consider the factors of the constant term at the end of the polynomial to reduce the number of guessing checks that you have to do. Then use long division to find the quotient after dividing by your factor, and then factorise the quotient if possible. Then you will hopefully be able to have a fully factorised version of p of x. So question number 1 says I want to solve this equation. Now we're used to solving quadratics that are factorised. This is just an extended version of that. If I have a completely factorised expression equal to 0, that means that any one of those brackets could be equal to 0. So either the 2x minus 7 equals 0, or the x plus 5 equals 0, or the 3x plus 2 equals 0. And I solve each of those. It's basically null factor again to find out what x is equal to. So for the first one, move the 7 across and divide by 2. So we get 7 over 2, or 3.5. For the second one, we move the 5 over, so x is equal to minus 5. And for the third one, we move the 2 over and then divide the 3, so x is equal to minus 2 over 3. Okay, well that's all well and good if it's factorised for us. What if we have an equation that is not factorised and is equal to 0? Then I have to do all that work factorising it myself. So the first job is that we have to find a factor. This is a cubic polynomial. I can't factorise cubics, so I have to find one factor at least by doing some guessing and checking. It's a little bit of an educated guess because we have this number 24 on the end, and hopefully there should be some factors of 24 that will work. So we say the possible factors would be possible factors of 24 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, 5 doesn't work, so plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. That's a lot of numbers to check, but we only need to find one that works. So we would start at p of 1, and we get our calculator ready, and we would sub in 1 cubed plus 9 lots of 1 squared plus 26 times 1 plus 24. It's equal to 60. So unfortunately not a factor. It has to equal 0 if it's a factor. So then I'll move on to -1. And if you've put it in your calculator, you just go through and change all of the ones to -1s so you don't have to retype everything. That'll make you a little bit faster, save you a little bit of time. That equals to 6, so still not a factor. Moving on to 2. You type that in. You delete the -1 and change it to a 2. Which equals 120. Still doesn't work. -2. So change them all to -2s. So this is can be a long process till we just need to find one factor. Oh, there it is, 0. We found one. So this is the one that worked, which means that x plus 2 is a factor. It's always the opposite symbol when it's in that form. So now, rather than keep guessing, because I could be at it all day on my calculator checking all those numbers until I find them, so instead I'm going to use long division to find the remaining factors. So I have x plus 2 was the factor that I found, and I'm going to divide my polynomial x cubed plus 9x squared plus 26x plus 24. Okay, long division. We do x cubed divided by x is x squared. Times in the x squared by each term in my divisor. X squared times x is x cubed. X squared times 2 is 2x squared. Draw a line and subtract the columns. The x cubes subtract to give nothing. 9 take away 2 makes 7x squared. Bring down the 26x, ready to do the process again. So now I do 7x squared divided by x, so that's plus 7x. Timesing that out, we get 7x squared, and then 2 times 7 is 14x. Subtracting, the x squareds disappear. 26 take away 14 is 12x. Bring down the last term. One more divide. So we do 12x divided by x is 12. Timesing that out, we get 12x plus 24. And because x plus 2 was a factor, it should always work out that that final number is 0, that we have no remainder, because it should divide exactly if it's a factor. So what I have worked out is that my polynomial, p of x, is the same as x plus 2, the factor that I found, times by the q of x, which is this on the part on the top of my divide sign. So x squared plus 7x plus 12. Now that second bracket is a quadratic that I can factorize even further. So I'm looking for numbers at times to give 12 and add to give 7, which would be x plus 3 and x plus 4. Now that it is fully factorized, I can use null factor to read off the solutions, because if this was equal to 0, remember, if my polynomial was equal to 0, which was in the original question up here, that my polynomial is equal to 0, then I can use my null factor. X would be equal to -2 from the first bracket, from the second bracket would be -3, and from the third bracket it would be -4. Okay, so it's quite a long process. We want to do that again. We're going to do the same process for question 3. I want to solve this equation, which is x to the power of 4. Because this is the power of 4, I can only factorize quadratics. I need to be able to find at least 2 factors by guessing and checking, so that will leave the quadratic left for me to factorize. So my possible factors of the 36 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. 5 doesn't work. Plus or minus 6, plus or minus 9. What else? Plus or minus 12, plus or minus 18, plus or minus 36. That's a lot of numbers to check, but we need two things to work. So we're going to start at P of 1, the very beginning. And we get our calculator out and we carefully type it in because we know we're going to keep changing the number so that we don't have to retype it every time. So if I go 1 in brackets to the power of 4, then I have to go minus 2 in brackets 1 cubed, then minus 11 in brackets 1 squared, plus 12 times 1 plus 36. So that is equal to 36. Then you would go through and change all those plus 1s to minus 1s. I'll save us a bit of time. That's equal to 16, so still not a factor. Go through and change it to P of 2. Still equal to 16, so not a factor. When you get to P of minus 2, it finally equals 0. So you found yourself your first factor there. But remember, we need 2. So we keep going. P of 3 is also equal to 0. So there's the 2 factors. Because I have found 2 factors and I need to do a long division, I need to take the 2 factors that I found. So the first one was minus 2, which will be x plus 2 when it's in brackets. And when it's a plus 3, it would be x minus 3 in the bracket. I need to expand that out because I'm going to do long division with this as my factor. So x times x is x squared. X times minus 3 is minus 3x plus 2x and then minus 6. Collecting my middle terms, I get x squared minus x minus 6. Okay, setting up my long division. I am dividing my degree 4 polynomial by the x squared minus x minus 6. My 2 factors times together. So let's divide. We have x to the 4 divided by x squared, which is x squared. Timesing that back out, we will get x to the 4. X squared times minus x is minus x cubed. X squared times minus 6 is minus 6x squared. So because there's 3 terms in my divisor, we're going to be doing 3 at a time down here under my divide sign. So subtracting, the x to the 4s will disappear. Minus 2 minus minus 1, so plus 1, makes a minus 1 or minus x cubed. Minus 11 minus minus 6, which is a plus 6, makes minus 5x squared, and bring the 12x down, ready for the next one. Dividing again, minus x cubed divided by x squared is minus x. Timesing the minus x by each term in the divisor, we get minus x cubed. Minus x times minus x is a plus x squared. Minus x times minus 6 is plus 6x. Subtracting, the x cubes will disappear. Minus 5 minus another 1 will be minus 6x squared. 12 take away 6 is 6x, and then bring down the 36. One more divide. Minus 6x squared divided by x squared is minus 6. Timesing that out, we get minus 6x squared. Then plus 6x and plus 36. So all those terms are the same, which means my remainder is 0. Okay, so I've found out that my polynomial, my first 2 factors were, when they were factorized, it was x plus 2 and x minus 3. I have now found that when I divide that, I get a quotient of x squared minus x minus 6, and this equation is equal to 0. Now I can factorize that quadratic in the last bracket to hopefully get 4 different brackets. So let's have a look. What times is to give minus 6 and adds to give a minus 1? That would be a negative 3, so x minus 3 and an x plus 2. Now, funnily enough, that means that some of these are repeated. I have 2 brackets that have x plus 2, which means that's x plus 2 squared. And I have 2 brackets with x minus 3, so x minus 3 squared. So we call those double roots or double solutions. So instead of having 4 different numbers, they're doubling up. And I'm only going to have 2 solutions for x. So from the first bracket, I would get that x is equal to minus 2. And from the second bracket, I would get that x is equal to a positive 3. Okay, that's it for our theory today. You now need to work on exercise 10F.